Hello everyone and welcome to C++. We are back to programming. This is the Abyss Mac Tutorials and thank you for joining me. So I know I haven't been on YouTube for a while, sorry about that. Very busy with other stuff, mainly cryptocurrencies. But we are back with programming, and so we're going to start off with C++. C++ is a language that balances performance and ease of development fairly well. And so what you see right now is this chart of languages that I've made, and it's real rough. There's tons of languages missing. There are hundreds of computing languages. Don't try to learn them all. But there are hundreds of computing languages. These are some of the more popular ones that I've taken and kind of organized into a list that explains the merits and drawbacks of each one. And so as far as how these tutorials are going to work, I'll just insert this real quick. I'm going to try to make these tutorials a little bit shorter than the other ones and just have more of them. I'm not sure how that's going to work out because I tend to ramble on about stuff, and usually when I ramble I provide good information, I like to think, but a lot of times I end up repeating myself a lot and saying the same thing over again. See what I did there? So I'm going to try to avoid that. I'm going to try to condense them a little bit more and stick to stricter timelines, I guess, so expect maybe 10 to 15 minutes per episode, and then each episode will probably cover less material, but it'll cover it a little bit more in depth, and then they'll be released more often. So that's kind of the plan for now. I don't know how it's going to work out, and I'll make adjustments accordingly as we go on. However, welcome to C++. This tutorial is going to be getting you from absolutely zero programming knowledge all the way up to knowing C++ fairly fluently. And so, as a result, if you already know programming, this tutorial will still, of course, work for you. It's still going to be covering everything you need. And I'm going to be making references to, oh, if you know Java, this will look familiar. Oh, if you know Python, this will look familiar. I'm going to be referencing other languages or general programming ideals or ideas, things like, preprocessor directives or object-oriented programming or pragmas, macros, things that have application, of course, among a bunch of different languages, and I'll point that out along the way. So if you already know programming, great. There will be little extra tidbits thrown in that you'll be like, oh, I see how that fits together, or oh, I see how that works. But what's really important for this tutorial series is that you come into it whether you already know programming in another language or already know C++ and are just kind of brushing up maybe, or are completely fresh, you don't know any programming, you're just interested, is to approach these tutorials in the way of, if I'm going too fast, slow down, rewind a little bit, rewatch. Don't pass a tutorial, don't glaze over anything that you don't understand. You don't have to have a full understanding of every single thing we do in the tutorials, but be able to implement it on your own, be able to run the code, know what it does, ask for clarification in the comments if you need, get involved, get engaged, make sure that these tutorials aren't just something that you're watching to, idly kind of be like, oh, programming, get involved, make sure that code compiles and runs, make some modifications, have fun with it, and really make it into something that you're not just learning to learn, but learning for some kind of purpose, because you want to make games, because you're in a class for it. Make it into something for you. So, of course, you could watch these for entertainment, but that'd be really weird. The main point is, make sure you get out of these tutorials what they're meant to teach. Make sure you understand the concepts before moving on, because if you move on without understanding the basics, these are building on top of each other. So while you don't need any programming knowledge right now, coming out of this tutorial and the next tutorial, you'll have a small little basis, and you'll be able to start writing small programs, doing some mathematical computations. This tutorial is going to be mainly talking about the differences between languages and why C++ is a good language to learn. So it's kind of like an introduction almost, but the next tutorial will certainly be covering some code. We'll be adding and subtracting numbers and talking about syntax, and so the first few tutorials, perhaps bar this one, will be a little bit complicated if you don't already know programming. Work your way through them, rewatch them if you need to, ask questions, get clarification. A lot of the things are very, very important, and they're things that you're going to be using constantly. And so these first videos are kind of hard. If you can get through the first 3 or 4, then you are doing really great, and from there everything else will become easier. You'll be put in that mindset. The hardest part of programming isn't actually the language itself, it's the thought behind it. Once you learn one language, learning another is simply a matter of syntax, basically. It's learning, well, how do I express this or how do I express that, and learning the limits of the language so you know what things do and don't move over. So, that being said, let's look at this chart. So this chart here compares a lot of the common languages that people use every day for computer programming. Mind you, there are way more languages than this. These are the main ones, these are the big ones you hear about, these are the ones people are usually interested in learning, but there are hundreds of programming languages out there, and each have their own specialties. Each are good for a certain purpose. Some of them are just kind of a joke, like a couple of the languages, brain and then the F word, that is kind of a... The language was basically an attempt to see how small of a compiler you could possibly make. And the language literally consists of 8 special characters, like periods and commas and colons and semicolons, and that builds the entire language. Anyway, so these are the popular languages, the ones that you will actually be getting jobs for knowing. These are the ones that are good to understand and have at least a working knowledge of. Of course, you don't have to learn all of them. We're learning one right now, which is C++, but it's good to have a working knowledge of a good amount of these. Towards the bottom of the list, you'll find that these languages are harder to learn, generally, and may not be the best starting place for learning programming, but they'll certainly work just fine. And you'll find that the ones at the bottom of the list are usually longer to develop in, so they take a longer period of time to produce code. As a programmer, they take a longer time to figure out how you want to do everything and get it drawn out and tested, but they're usually faster and they give you more control over the system. Then in the middle, you have your languages like Java and Python, and these languages are going to be generally easier to pick up, a little bit more forgiving perhaps on the code, a little bit more accepting of different ways of expressing things, and a little bit more giving with what they provide in APIs at the cost of performance. These will perform a lot more generally slower than the other languages below them. So as you go up the chart, performance decreases. As you go down the chart, development time increases. So it's a trade-off. Of course, if you know C++ way better than Python, you will be faster at writing stuff in C++. But this is assuming you know every language equally, or you were choosing a language at random for a certain purpose. You would choose one that fits your project. You have a short deadline and the app isn't very computationally intensive and maybe it's going to run on a powerful computer. Alright, choose a higher level language. This program is mission critical for performance and you have years to develop it. Maybe assembly. So there's also the benefit of higher level languages of being more platform independent. So when you think of processors, you probably think of an Intel processor, the thing inside your computer, your tower, your laptop, or maybe you're thinking of the processor in your phone. Either way, there are a lot of different processor architectures to consider. So, for example, you have in your desktop probably a 64-bit processor. If you're on an older computer, you may have a 32-bit processor. 32 and 64-bit just describe the length of memory addresses. Often they're called, for 32-bit, I-386 or 486, 586, 686. Those are Intel compliant standards. But so you'll usually think of, 32-bit or 64-bit, but there's a lot of other processor architectures. For example, like ARM, which is what's commonly used in phones nowadays. And each architecture has their own instructions, and those instructions are just things it knows how to do. This isn't necessarily relevant for learning C++ per se, if that's all you came here to do. Definitely skip to tutorial number 2. This is an intro to computing and programming in general. Really good if you have no prior programming knowledge and you just chose a language to learn, and you're kind of making sure that you chose the right language. But if you already know you want to learn C++ and you don't really want to have a deep explanation of the different languages, definitely skip on to tutorial 2. You won't be missing anything too critical. But assembly is a lot harder to write. It's not nearly as human readable. Source code's longer and harder to parse through and read. But you have extreme control over that processor. As well, when you write for a specific processor, it won't run on other processors. Now, of course, you can write a 32-bit program and have it run on a 64-bit. Sometimes there's that forwards compatibility between architectures. But I can't write something in 32-bit and expect it to run on an ARM processor if I'm writing in assembly or even in machine code. So what you end up doing is creating languages that can compile to assembly, that can be converted to assembly. And these languages are the C family, C and C++. These languages, you can write it in human-readable code and then compile it and it'll generate assembly. You have less control over what's actually going on under the hood of your system, but it's faster to write, easier to read, easier to maintain, and it's cross-platform. Someone makes a C++ compiler for ARM. Suddenly you can write your C++ code and have it run on ARM. Or say you want, to have your program run on x64 processors. Well, you just need to find a compiler that will generate x64 assembly from your C code, which they're everywhere, and all of a sudden your program now runs on that platform. So you get that cross-platform ability, and when I say cross-platform, I'm talking about processor architectures, not OSs at this point. Step up a level further, you get to languages like Java and Python. A lot of these languages are run in VMs, per se. They are run and virtualized on top of the hardware. So, for example, Java bytecode will look the same on any system that you're running it on, but when it's interpreted by the VM, it's run differently based on, the processor and everything in the machine. But the actual bytecode, which is almost like kind of Java assembly if you want to think of it like that, but that's not really a good way to think about it. That will look the same from platform to platform from a Java program, but when it actually runs, at some point, of course, it has to be converted to instructions that will run on your CPU, usually using something like just-in-time compilation, things of that nature. So again, not important to understand what those are per se. You can go look them up if you're interested, but these languages will have a lot more cross-platform abilities on the OS level. So cross-platform on the hardware level, C family. Cross-platform on the OS level, Java, Python, the virtualized languages. And then as you go up more, you get to even easier development. You have HTML and JavaScript. Those aren't really languages you'd write professional apps in. As far as programs that you download and run on your computer, that's not the venue for those languages. Those are web-based languages. Those are languages that websites are built out of, and they're very good at what they do. They're very good at defining layouts for websites. You don't write websites in C++. That doesn't make sense. Browsers don't understand C++. They can't interpret it. You need some kind of language that can be live interpreted, but you have the cost of performance. If you built the exact same app in HTML5 and in C, some kind of like 3D graphics app, the JavaScript app, because of the layers of abstraction it has from the processor, would take a lot more clock cycles in most cases. A lot of times those languages will also have bindings. And a binding, we'll talk about what bindings are later, but they have bindings to lower language functions, so they can do stuff like OpenCL or OpenGL kernels or things of that nature. OpenCL kernels anyway. They can run those through bindings, and so they can accelerate through and get the performance of some of the lower languages, but often in that you'll be writing in those lower languages and inlining it or inserting it into your code. That's the other thing. Some languages can be mixed, some can't. You can't just mix Java and C++, you can't put them in the same project and run them, but you can, or compile them I should say, but you can put something like assembly inline into a C program, and so you can write some mission critical part of the code that performance is really, really super important, and you can inline that into your C code. And in order to be able to do that, you will be taking this kind of chunky C++ or C code, and you'll be inlining some kind of assembly instruction that you yourself wrote, and then it'll execute that as it's going through procedurally, if you will. And so you can insert assembly into those programs. So it just really depends on what you're looking at as to whether you can mix or match languages, but as a general rule, mixing languages for a project isn't a good idea. There's some cases where you may write a server in Java because it's faster to develop and easier for you to maintain, but you write the client in C++ because the client has a lot of 3D graphics it has to take care of, and you want performance to be a consideration. But on the server, it's just sending back and forth text, so it can be a very slow implementation and still be perfectly fine for its job. So sometimes there's that mixing, and a lot of times networking protocols and stuff will be a great way to transfer information between programs written in different languages. There's also something called a wrapper, which is where you write something in a language that wraps around something else written in either that language or another language. For example, if there is some kind of C++ program that you like using and you want to build it, and it's a command line program and you want to build a GUI, you might write a Java GUI, a program in Java that it has the GUI and that it does the command line interactions with the C program. For example, I made one of those for Reaper, which was a program that, and still is a program for mining Litecoin, if you know about Litecoin and cryptocurrencies, and it was actually for mining script coins using the script algorithm, and I made a simple little Java GUI that wrapped around it and controlled it, so you could click buttons instead of typing in commands and changing config files and stuff. So you can have that wrapper, that ability to take an easy language and make it mold to a harder language, but a lot of times that's not the most efficient way if you have access to the source code. So on one final note, why are you learning C++? C++ balances performance and ease of development really nicely. C is going to be harder to develop in, a lot of things aren't provided for you. C++ adds a lot more support for things. It's still not as powerful as Java as far as what's already built into the APIs. It doesn't provide that same level of, right off the bat, you have access to everything. However, the important part is that it really does still let you have more direct access. You can manage memory directly. You have closer control to the CPU. So to give you a little bit of an analogy to sum this up, because we're coming up on 16 minutes pretty soon, basically assembly, so say you want to write a program. What's the function of a computer program? To get something done, to do a process, to, if you were to compare it to real life, to tell someone to go to the refrigerator and grab you a soda, let's say, would be a program, if you will. You can kind of program or train people to do that, and then it becomes really useful. That's called real-world programming. Anyway, so what the different languages are. Assembly, you tell a person how they should stand up, how they should balance the weight on their knees, how they should walk, what speed they should walk at. They should move their legs like this, left foot, right foot, left foot, right foot, about 17 inches apart. They measure that 17 inches using triangulation from their eye, from their viewpoint, their eye, I don't know. And then to grab onto the door with the right hand, 2/3 up from the bottom, pull, open it 37 degrees, reach and grab a Coke, which will be on the top shelf left side, Coca-Cola, and then grasp it in their hand with, 170 newtons of force. And that's a huge amount of force. With some amount of newtons of force, and then turn around. That's assembly. All right, that's giving very specific instructions and controlling every single little thing that person does. C and C++ is more saying, hey, could you get up, walk over to the refrigerator, grab the handle, open it up, grab me one of the Cokes on the top shelf and bring it, make sure it's not expired and bring it over here? Thanks. That's C++ and the C language. C would be a little bit more specific usually. And then Java is like person.getSoda, and there's a method already for soda. Or maybe you have .getSoda and .getSoda calls walk and calls open refrigerator and calls grab soda and calls walk again. Things like that, and gives it positions. And then in HTML, there's very likely something that just says get drink, and then you put get drink soda or something of that nature. So the more you go up, the less control you have over things. So the easier it is for you, because the less you have to micromanage individual little objects and things and processes inside your program, the more they're done at a top-level management scheme. However, the less control you specifically have if you want something done a specific way. That control is just not available, or is obfuscated or abstracted away from you in such a way that it's very hard to work with. So that was a quick introduction to programming languages, and our next tutorial, which will be uploaded at pretty much the same time as this, will be on C++. We'll actually be getting into code and talking about code. So remember, stick with me through these tutorials. If you have to rewatch them, rewatching can only help. The first couple are going to throw a lot of information at you. If you can get through the first few, it'll get easier from there. Even though we're getting into more complex stuff, the amount that we're introducing each time will get easier, and having that understanding, being in that mindset for programming, will really make everything so much easier. Once you can get in that mindset, which is after maybe an hour or two of watching videos and programming and tinkering with some code, once you get into that, you're pulling yourself away from English and you're getting into how to communicate your ideas to a computer, then you will really be able to move forward rapidly through learning programming languages. So, that being said, if you already know programming, you're doing great, and the next few videos probably won't be hard for you. It'll be more of a matter of learning syntax and being like, oh, that's how C does that. Oh, that's how C++ does that. The other thing I'd like to mention really quick, sorry this video is running longer than I thought. I guess I'm not too good at reducing rambling. But anyhow, this is also going to, at a later point, diverge a little bit and talk about security. Usually with Java, you don't talk about security much, but with C and C++, you have direct access to the memory a lot of times, and you're controlling memory, and there's the risk of things like buffer overflows, which we'll go into. They're a lot of fun. It's basically where you overwrite memory with your own code and run arbitrary malicious code on someone else's machine through some kind of exploit. And we'll be going over those and how to prevent against them, how they work, why they work, how the memory stack works. So at first we're just going to start programming and talking about that, but at some point in the future we're going to diverge and talk about kind of under the hood stuff as well as the security, while also of course learning new programming techniques. So at some point that diversion is coming, so if you're interested in cybersecurity, that's going to be a lot of fun. Additionally, we'll be reverse engineering some programs that we write, some of the real simple ones to C assembly, and kind of link that together with what's going on. So this tutorial we're working with Linux, as you can see. I don't really know why I have this VM up because we didn't do anything in it, but we're working in Linux. However, since C++ has some things that work in Linux differently than in Windows, when those occur, I will switch over to Windows and say, hey, okay, so that's how we did it in Linux. Here's how you do it in Windows for some of the things. So, thank you for watching, and I will see you next time. If you have any questions, feel free to leave them in the comment section or send me a message.